Recording is in progress. Good evening, y'all. This is Code Platoon, Hotel Platoon, uh, Module 3, Databases, Week 9, Day 2, more SQL queries. We'll be doing joins. Um, a lot of times, you can kind of pull out a bunch of data and mush it together, um, and that's just fine. Learning how to do things the most efficient way in SQL is kind of worth the squeeze. Reason being, if you were to just pull a ton of data out and then work with it after the fact with Python, perhaps, if we're talking big amounts of data, that's just not going to be scalable, right? Um, and you can just save yourself a ton of work by doing a lot of the filtering and joining on the front end, which is what we'll be doing. Well, I say front end, I mean database, right? Where it comes out. Um, you're not going to find many ways to get this information faster if it's in a database than with raw old SQL, which is why this is a continued, used skill. People will just write raw SQL out of databases to get stuff as fast as they can. It is a real thing. If you don't working in massive data and speed isn't a huge issue, you might not be using so much SQL, but we're going to learn it. We're going to be able to write our own databases and continue on. These queries will be made against the car's database. Let's walk through setting that up right quick. I'm sure y'all maybe did it yesterday, but we're going to do it now. Um, I like to look at this because there are different, excuse me, there are a bunch of different ways to query a SQL database running really anywhere. Um, but on a Docker image, sorry, in Docker, like we will be doing here, um, you can hop into the database and then run these commands manually. That's fine. You can hop onto the Docker container and run a script. That's fine too. Best, in my opinion, is to run it without ever hopping onto the container. Just running it remotely with a script. Um, Manually running these SQL, commands is really good for learning, and I'm not going to tell you not to do that. But getting in the habit of writing a script that is going to kind of fire through everything, um, I like that work practice a little bit better because you're more likely to have a good understanding of what it is you've already done. You can see what it is you've already done. Um, and it's more akin to really the way we need to be treating databases, which are these persistent, valuable storages of data, right? We're not going to be willy-nilly hopping around on them, creating new tables, dropping tables. I want us to at least think about it before we run these commands. That's why I like scripts. As far as the lesson today, I think we'll be doing a little different. But here we go. Docker build T cars database. Oh, I need to clone this down first. Let's do that. Yeah, clone. There it is. There's our Docker file. That'll build it. Is Docker running? Docker is running. And we can just run it like that. If we so choose. All right. Docker PS. We're up. Oh, I got a bunch of junk laying around, don't I? Hmm. There we go. Just the cars database. If I want to exec into it, I always get my commands backwards between Kubernetes and Docker. Give me a sec. And then you don't do the dashes. Okay, got it, Jordan. There we go. We're in. Once we're in, this is how we can run. Oh, sorry. This is how we can get up in that database. There we go. So pull down the repo, build it, run that image. Now we have exec into this image. I am more okay with you doing this on a running container than locally. You could brew install PostgreSQL and be working on your local machine with all the powers of root and everything. Um, and I think that's messy. Uh, I would like to keep your databases contained in these containers that we can replicate and rip down and rebuild. That's just me. Um, this is where we're going to do it while you're in my class. So that's up. Group by is the first thing we're going to talk about. You remember aggregate functions like count and average? There are times where you don't just want to count everything on the table, but instead want to get a count per X. For example, we can get a count of all the distinct models. Easy peasy. Select, grab all of them. Count, I want the number. That's what I care about, not really anything else. Distinct model, basically ones that are, unique. From car model. Let's see if this runs exactly the same way. It sure does. Um, Different than something like that, right? This is going to get all the distinct model types, right? Model, make, model, model. There are 99. Good. Questions about that? If I scroll
Nope.
through this for only distinct, I should find 99. Cool beans. But what if we want to get the count of models per make? Well, there are a number of models that are on the same make. I want to get all the count for each of these. But these are two different columns, right? And I'm making a new table out of it. I don't want this table. I want a table that has the stuff I want on it. So we're going to count everything, but we're going to be, oh, I'm sorry. We're going to display a count of everything of the makes. So from car model and then group by make. What's that give us? Excellent. Grab all the makes, count them up. That's what we're doing. Group by make. Group by meaning I want them grouped here, and then I want you to count them. So we're counting everything, but I want to display the make, and I want them grouped by make. So once we've grouped all the makes together, I want all those counts to display, and then we're going to join that with its count, make and count. What I was going to suggest is what we're doing next. Let's clean that up a bit and order them by the biggest. All we're really doing is tacking this on to the end, right? Uh, Order by, count, descending. I would sure expect to get almost the same output, but higher numbers on top. Seem good? And what I was about to say. um, you can multi-line SQL as much as you want. It doesn't really care as long as you end it with a semicolon. And we'll see a lot of SQL written in this way, but remember, just kind of like JavaScript, it doesn't really care as long as the brackets make sense and spaces make sense and semicolons are where they're supposed to be. Same dang thing. Building by group by is a little odd. Let's say we want to get the count of models per make, but we only care about Volvos, Fords, and Kias. You might think this, but let's try it. So we're pretty much running the exact same query, right, that we did up here. And then where make in Volvo, Ford, Kia. Uh-oh. 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 We'll do that. Yeah, we get the same issue. The problem here is when filtering a group by column, you have to use the keyword having instead, which is great. You would think you'd be able to use where for this, but when you're grouping by, we have to remember having. There's not too much syntax in SQL, but there is a little bit that we do have to remind ourselves of, and that's a good enough reminder. That's fine. Syntax error, easy peasy. Oh shoot, what is that called? Man, my brain isn't chugging quite as fast as I'd like. There's a way to suggest a change in SQL, see if it would run, and then to run it. I need to look at that before I let y'all out today. Um, so all we've done is change that syntax to having. We are again going to count them all, the makes from the car model. We're going to group them by the make, but we only want these three. Look good. Questions about that? No questions about that?
Nope.
Art.
A little fuzzy on this, but could, does like work the same way as having, like, let's say we wanted to just pick out certain models using that I forget the percentage sign. So I guess my question is, what's the distinction between having and like?
Good question. And I wasn't prepared for that question. Let's find out, huh? SQL difference, having and like.
I
I
guess I could do that. I'm sorry.
well, I don't mind looking it up because I might be able to help explain it. Well, that's very useful. Like operator. All right, here's the meat and potatoes. Used in a where clause to search for a specified pattern. Yeah, we can get away with like when we're using wheres. When we group by, we need to use having. Um, that's it. Does that make sense?
Yes, thank you.
So just like where isn't going to work when we're grouping, and we have to use having, we're going to use like instead of in. But yeah, honestly, I think really what this is trying to show us, I don't know that I trust that answer 100%, is in is giving us a list of things. I don't think like is going to let us do that. I think like wants a single command, right? Um, see, thanks for being useless, AI. Yeah, the difference really, if you want Jordan's answer, like is good if you're comparing one thing. But if we want to say, hey, in any of these things, it's in this list of things, that's when we'll use in versus like. Does that make sense?
Yes, thank you.
All right. Put me on the spot, ask me questions about SQL, which I love. Joins. Joins. Uh, Group's good when we have a table and we want to look at different things on the table. Join is when we need things from separate tables, right? Joins can seem very straightforward. They also can confuse the heck out of you when people go nuts with them. We're going to keep it simple today. We're going to stick with inner joins. We're not jacking with left, right, or full. That'll come later. We are just comparing two tables on some comparison and then displaying what it is we want uh, of all those things. Um, let me, I want to break this up better, but let's see. Select star from app user, enter join advertisement on yada yada. So what are app user and advertisement here? What are we trying to do here, do we think? Do we recognize these?
Different tables.
Absolutely. They're just different tables. So we're going to get everything, all the columns from this new table. We're going to combine and create some new table. It should have more columns than either of the other tables. We can prove that. Oh, no, 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 no. Select star from app you. Oh, no, no, no. Is that right? Oopsies, forgot my thing there. James Butt. Account ID, first name, last name, email, password. That is the first table. That's another table. I'm going to expect to see all of these rows, sorry, columns, uh, on the one new, larger, gigantic table. So give me all of them. I want all the columns from, ooh, I don't need your help, Cascade. App user, which was our first table. Inner join, just where they line up with advertisement. What are we joining on? Well, I want to join the two tables where they're similar. How do I know what to join them on? Wherever app user.account ID is equal to advertisement.seller underscore account ID. Just five. That query informs me, or at least I can make an assumption. Can we make that small enough? Is that too small for y'all to see? I was just trying to, I'll blow it back up. I just want you to see it all. Um, a query such as this makes me think that these are always going to be real people. If you have an advertisement seller account ID, you must basically, you have to be an app user to buy something, right? Or sorry, to sell something. If you're the seller account ID, you must be an app user. So it would make sense to me that they're both going to be the same. I know we're talking about an app that we didn't design, but am I losing anyone here? It's okay to say, Jordan, that explanation wasn't good.
Is it common then? I'm trying to think if I've seen this elsewhere, but is it common then to join tables off of, because these essentially are primary keys, right? The account ID and the seller account ID. Is
Correct.
it, but it's not uncommon. We can join them wherever we want, but it generally would make sense to join two tables off of the primary key.
Yeah, I mean that's a good thing. They're generally going, well, generally, they better be unique, right? A primary key is going to be unique. And I kind of misspoke. This account ID, yeah, that is going to be the primary key of the app user. However, this is not, again, I'm guessing. I didn't write the, I'm not guessing. We can go look at it on the table. But this advertisement probably has an advertisement ID, but that's not what this is. This is the seller account ID, which is associated with one of these guys. It's probably a foreign key saying, hey, when you make an advertisement, do y'all know about foreign keys yet? Did we cover that yesterday? I don't think so, huh?
Yeah,
Well,
it's definitely not the primary key. You're right.
you're asking a good question, so we're going to go down that rabbit hole. An app user is going to have an ID. All of them are going to have an ID. You're the first one in line. You're number one. Sorry, zero. Um, but the seller account ID is going to be a foreign key. Basically, I'm going to set my database up as though if you want to do an advertisement, you better give me your account ID also so I know who this advertisement belongs to, right? That makes sense. You don't want to have an advertisement out there floating to the world just saying for a good time call. Like you need to have your ID there, right? Does that make sense? So it's going to be a foreign key. You can't just have an advertisement and know seller ID. So it's going to be required to connect back to an app user and their account ID. Does that make sense? This is a
Yeah.
new concept, but hopefully I'm helping out a little bit when you get to the instructor that's going to teach foreign keys. Um, limit 5, that's them. So, well, we limit it to 5, but as you can see, this account ID is 59 and this seller account ID is 59. And then we're just displaying everything. Um, so this is all the data between the two tables. Great. This looks like the app user. Well, app user is what's on the left. So this is the first thing. Inner join advertisement is on the right. Advertisement ID, advertisement date. This looks like all advertisement stuff to me. So when I'm talking left and right, it makes more sense, when it's written out and there's no spaces. But that's the one on the left. That's the table on the right. Okay. Well, this is just the same thing, and I just broke this up. Do we have questions about how I built this table here? This query of two tables. All right. I disagree. The last clause is often the most difficult part to figure out. Not here. I want to, group them by IDs. That was a logical thing. We need to tell the databases how we want to connect rows from different tables. So we have to find things that are similar. In this example, we connect, yada, yada. We sure did. That's repeating everything I just ranted to you guys about. Note that an inner join will only return rows where there is a match on both tables. For example, there is one user who has placed no advertisements, Janny Biddy. You can see she doesn't show up in the above query. We can test that. The exact same query, and then we're using where to look for this first name. I'm about tired of you, Cascade. Uh, and last name, Biddy. We should get nothing because she doesn't have any advertisements associated with her. Even though she sure does exist, doesn't she? Oh, I don't like how I set myself up for failure there. There we go. Select the arm from Uh-oh. Does Janie Biddy not exist? Does she not exist? Let's find out. Is that right? Is that a good command? App users? That's a right.
Yep, she doesn't exist.
We'll just make a little change here. Uh, create a new branch. There we go.
It is actually it's one N, not two N's.
Ah, still making that pull request. Goodness gracious, how did that happen? Did I fix this last year? Did I unfix this last year? That's all right. At least, you know, I need to stop being an idiot. At least we can prove that we're not crazy. There we go. All right, back on track. Back on track. All right. Good. Let's look at one final example. So let's get the number of car doors for every make and model. Believe it or not, we've got some with five. Uh, I don't know if I believe that. Is that a real car? Has anyone seen one of these?
I haven't
Yeah, they're
seen a
popular in
308.
Europe.
Ah, all right.
It's a stupid, dump looking car.
We'll get it for the tube. Yeah. I mean, that's fine. It's not that offensive. Okay, so select car, model, make, car, model, model, car, number of doors. We are going to, what are these? What is the select getting us here? Where do we expect to see this? Don't look at the answer down here.
Your columns in that particular table.
Yes. What's this and what's this? Adam.
From the graph car
Graph.
or
Have
not
I used
graph,
graph today?
but what is it called?
You eat on it sometimes. You could sit at it.
Table? Table.
Yes. And you
Okay.
flip it when your students aren't paying attention. Yeah, so table and table, right? These are our columns. These are the two tables. What's this? What's this? What's this? What's this? What's this? Nicole, these, sorry.
Where the two tables columns match. So
Correct.
the column from car and the column from car model.
Okay, so if I've got a car with car model ID 7 that doesn't exist in this table, will it show up?
No.
You're right. What the hell is this? Cisco throwing you a slow pitch?
You're just limiting the results to 10.
All right. Trying to get everybody. There we go. It looks like the answer. Seems good. Uh, this is all we're displaying. If we wanted to display more, though, right? Like if we, here's the thing with SQL. If you get what you want, great, that's fine. Um, just when stuff's small enough, when the tables aren't, we don't have dealing with 1,000 columns or whatever, we can look over this stuff and make sure we're not crazy. Let's just see if this all makes sense. Um, So I've got car ID, number of owners, registration number, manufacturer year, number of doors, all that. I think this is about where our first table ends, right? So this is the first. This is one on the left, car model, and then here is the cars, all the other junk. So these are the two tables we've mashed together, right? If I was building this out, I'd do it step by step. Um, and then we said, okay, actually, only these three columns are important to us. So make, model, number of doors. Where is our make, model, and number of doors? M, N, N. Are these in alphabetical order? Is that the order in which they're displayed? Yeah. So we could have known that make was going to be on the left and then model and the number of the doors if you really cared that much. Cool. You can join multiple tables together in one query. Let's say you want to get the distinct street names of anyone in New Orleans who placed an ad in May of 2014. You go look that up, right? The product owner doesn't have time for that. They want you to go look it up. It's not hard. We're just gonna do this twice. Instead of a single join on, or sorry, from. Uh, oop. All right, let's slow down. Let's digest this. I'm trying to go too fast. Select distinct P street name. Already tossing in something new. What the hell is this P street name? Anyone take a guess? Read ahead. What is P? Art.
Let me see here.
I am making you guess without telling you. I haven't taught you. I'm making you guess from context clues, which I think is better than giving the answer.
Is this payback for that like having and like thing?
Yes. No, I forgot about that already.
P dot street name dot P. Guessing. I mean, we've seen P before, like in HTML for like paragraph. Um, it's not column.
I'll throw you a bone by kind of giving you the answer because I think we're going down the wrong path with this. It's just an alias and it's established right here. When I reference a table, I can give it an alias if you
Oh,
want to. You don't have to. But a lot of this stuff can get rather large, table names included can get rather large. We say here, which you would sure want to see this before it's ever referenced, but that's just SQL for you. You can't always read left to right and it makes sense. User profile is P. So every single time I see the word P, that's just user profile. App user is A. So A. Add is AD for add. Um, but here are our three different distinct tables, and we're throwing something new in there. In fact, I would reverse the order that we're showing you this. Here it is without aliases. Is that way harder to read? I don't think so, but here it is. Select distinct. Let's not forget what we want to do. Distinct street names of anyone in New Orleans who placed an ad in May of 2014. Where is that? I don't know why we're setting the ad there. Doesn't matter. So select distinct, got it. From user profile, our first table, join on app user, where profile account ID, app user account ID are the same. That makes sense. That's not crazy. This is all good. We've done this before. Now, that's our first. We got a table of these two things. Don't take my word for it. Oops. Oops. Here's what we got so far. This is our first thing. We are displaying only the distinct user profile dot street name between these two. So wherever a app user account ID and user profile account ID are the same, we want a distinct street name. Looks good, right? Just street names. Now we're going to join an advertisement where I'm using the word where advertisement dot seller account ID is equal to app user account ID. We're doing kind of the same thing except for advertisements. We just want that seller account ID and we're going to still compare it to the account ID of the app user. Let's add that to our query and see how it changes. Nothing changed because we're still only displaying the street name. Let's get rid of that so we can actually see what's going on. There's not an easy way to go up. Sorry, guys. What's that going to do? Yeah, make it way too complex. Teeny tiny. But we are joining three different tables at this point, right? I'm displaying everything. You probably can't see that, but I see app users. And then, oh, goodness gracious. I see app users, then I see user profiles, and now I see some ads. So we do have three tables up to this point. Up to this point. Now, I only want where user profile city is New Orleans. Well, there's two. but that's good. So we found the two who are on unique streets uh, in New Orleans. Lastly, and extract month from advertisement, advertisement date equals 5. Uh, we're looking for 5. What is 5? I guess May. January, February, March, April, May. Makes sense to me. We're going to look at extract here in a second. There we go. Uh, give me 3 minutes to scroll back up to the top. Hmm. Is her name? What does profile have in it? First name. Does that work? Did I mess up? Did I break it? Oh, that's probably my problem. This is another reason I like to do this in scripts and not directly on the database. So I can get around a little faster in Vim. Oh man. All right, well, I'm not gonna lose my mind and show y'all something that we don't need to see. Takeaways. Do stuff one at a time, line by line, make it make sense. You can join two tables. You just have to choose what it is you're connecting them on. You can join a table onto that table, but consider, up to this point, we had two tables, now one, and then we can grab another table, continue to join on it. Then we filtered them down New Orleans, and then we nabbed that, basically, losing my mind. The street name, goodness gracious, from the months in May. Good. Extract. Let's see what extract is. It's one of these many functions you can look up and learn about. Have I used extract before? No, only in this lecture. But there are some out there, right? That's it. We're not going to show you every, SQL function out there because some of them are pretty rare, but it's good to know that you can Google them and that's what they're called. If you feel like these queries are getting a little insane, just wait till week 2, where they're just mean. But the point of it is showing you a lot of tools so you can work your way through these kind of SQL queries. What I want y'all to do is understand how you can manipulate a single table, how you can manipulate multiple tables, how Jordan walks through these and builds them up, which is line by line, make them work bit by bit. But I want you to be able to read them as well and not be, uh, what's the word? Intimidated by them, I guess. Like we start getting, pretty massive queries here, but I want you to be able to identify what the smaller parts are so you can at least wrap your head around them and read them. Again, SQL is for these weeks. And then we're going to be doing this in something you're more familiar with is objects. We'll be using object relational mapping. They're going to look like Python classes, but this is what it's doing under the hood. Questions?